let's have a look at solving logs, but in a different scenario or different situation. So it says solve the equation blah blah blah. Give your answer to 3 significant figures. When you have a question like this, it's easiest to have a substitute. So the substitute that I'm going to take is y equals f to the power of x. Okay? What that allows me to do is it allows me to turn this equation into y squared minus 12y plus 20 equals 0, which is much easier to work with. 5 to the power of 2x is equivalent to y squared. Okay? From this point, from here, I just need to factorize. What would you get when you factorize? Y minus 10 and y minus 2 equals 0, which means y equals 10 and y equals 2. And now we take our substitute and we bring it back in. So that means 5 to the power of x equals 10 and 5 to the power of x equals 2. And now we do that equivalence. So x equals log base 5 10 and x equals log base 5 2. Question says to 3 significant figures. 1.43, 0.431. That's what you would get when you plug it into a calculator. That question comes up quite a lot, that format. So if you follow this method, you're going to be fine. Okay, that is one question. That's one scenario. Here is another one. Find the solution to the equation 3 to the power of x equals 2 to the power of x plus 1. Give your answer to 4 decimal places. In this scenario, what you're going to do is you're going to take logs of both sides, which means you're going to attach logs with the same base on both the left and right hand side. So log 3 to the power of x equals log 2 to the power of x plus 1, and we can make them both to the base 10. Okay, that log base 10 is like default. You can think of it as default. It's sometimes referred to as natural logs, I believe. So because it's the same and because it's natural log, we're just going to leave it as log with no base. But we're implying and we are automatically notating that it's got the same base. From here, now you're just going to solve using your log rules. So using the power law first, we get that. And then using the addition law, we get this. Now we can move all the x's to one side. Factorize. Then we can divide. And then you plug it into your calculator. When you plug it into a calculator, you would use log base 10. This would give you 1.7095. Cool. That is the other scenario which you might come across in terms of questions. So, have a look at question 2a. I want you to give that a shot for me, please. Okay, so we're going to let y equal 2 to the power of x, and we're going to rewrite it as y squared minus 6y plus 5 equals 0. You factorize, you solve, and you get 1 and 5. You sub those in. 2 to the power of x equals 1, and 2 to the power of x equals 5, which means x equals 0, and from here we get we can take log of both sides. So log 2 to the power of x equals log 5. X log 2 equals log 5. So x equals log 5 divided by log 2. So 2.32. These are our two solutions and our two values of x. Okay, that's question 2. Can you now try question 3 for me, please? So for part A, we can rewrite using the equivalence. So log base 3 2000 equals x plus 1. So x plus 1 equals 6.9186. So x equals 5.9186, or 5.92 because they want it to 3SF. Okay, part B. Again, we can do the equivalence. X minus 3 is equal to 5 to the power of minus 1. X minus 3 equals 1 over 5. X equals 3.2. So 1/5 plus 3, 3.2. And there you go. That's how you solve slightly harder log equations.